Have you ever looked up at the sky at 2 in the morning and seen the blinking lights of a large aircraft passing overhead? Most people assume it is a passenger flight running late, but the chances are it is not carrying a single person. It is carrying parcels, thousands of them, and it is exactly where it is supposed to be, at exactly the right time because the entire global logistics system was built around the idea that cargo moves while the world sleeps. Today, we are going to break down why that is, and I promise by the end of this, the way you think about overnight delivery will never be quite the same. To understand why cargo planes fly at night, you first have to understand what they are actually competing against. A package dropped off at a sorting facility on Monday afternoon needs to be somewhere else by Tuesday morning. That window is roughly 12 to 14 hours, and within that window, the package has to be collected, sorted, loaded, flown, unloaded, sorted again, and dispatched for final delivery by road. Every single one of those steps has to happen in sequence without a single gap. Miss one and you're back to square one once without a single gap. Miss one and the whole chain collapses. So the question is not just why do cargo planes fly at night? The question is why does the entire system only work if they do? The answer starts on the ground, not in the air. During the day, major airports are at or near capacity. Passenger flights dominate the schedule. Slots, which are the assigned windows of time in which an aircraft is permitted to land or take off, are allocated months or even years in advance. At airports like London Heathrow or Frankfurt, those daytime slots are among the most commercially valuable assets in the entire aviation industry. A cargo operator trying to compete for those slots against major passenger airlines is fighting a battle. It cannot win on price alone. But at night, the picture changes completely. Passenger traffic drops sharply after 10 or 11 in the evening. The runways are quieter. The taxiways are clear. Ground crews can move aircraft in and out of gates without the constant choreography that daytime operations demand. For a cargo operator, the night is not a limitation. It is the only window in the schedule where the infrastructure it needs is actually available. And there is more to it than just slot availability. Think about what happens at a cargo hub during the night. Companies like FedEx and UPS have built entire cities around this concept. The FedEx Superhub in Memphis, Tennessee is one of the most extraordinary logistical operations on Earth. On a typical weekday night, over 150 aircraft arrive at that single facility within a window of just a few hours. Every one of those aircraft is carrying packages from a different part of the country or the world. Every single package is unloaded, scanned, sorted by destination, and reloaded onto a different aircraft, all before the sun comes up. The entire operation runs on a schedule measured not in hours but in minutes. That kind of precision is only possible at night. During the day, the same facility would be competing with passenger operations for gates, ground crews, fuel trucks, and air traffic control attention. The complexity would make it nearly impossible to coordinate 150 arrivals within a narrow time window. At night, the cargo carriers have the airport largely to themselves. They can run their operations like a factory floor, with every movement planned and every resource dedicated entirely to the task. But why does the package need to move at night at all? Why not sort everything during the day and fly it the following morning? The answer is the promise that the entire express delivery industry is built on. When a customer clicks confirm on an overnight shipment, they are buying a guarantee. That guarantee only exists because of a very specific sequence of events that has to happen within a very specific window of time. The package has to be collected late in the afternoon or early evening. It has to reach the sorting hub before the aircraft departs. It has to fly overnight. It has to be delivered by road the following morning. Remove the overnight flight from that chain and the guarantee collapses entirely. The whole business model depends on the night. Now here's the part that most people have never considered. Night flying is not just more convenient for cargo carriers. In several important ways, it is actually better for the aircraft themselves. At night, air temperatures are lower. Lower temperatures mean denser air. Denser air means the engines produce more thrust for the same amount of fuel. Aircraft performance improves. On long-haul cargo routes, this effect is small but real, and over thousands of flights, it adds up to meaningful savings in fuel costs. Night flying also tends to mean less turbulence. The convective activity that generates daytime turbulence, driven by solar heating of the ground, largely disappears after sunset. Smoother air means less structural stress on the airframe and a more predictable flight profile. There is also the question of airspace. During the day, the sky above major population centers is one of the most complex environments on Earth. Commercial flights, private aircraft, military operations, and general aviation all share the same corridors. Air traffic controllers are managing dozens of aircraft simultaneously, often within the same sector. At night, that traffic drops dramatically. Cargo aircraft can fly more direct routes. They spend less time in holding patterns. They burn less fuel waiting for a landing slot. The efficiency of the entire operation improves simply because there are fewer other aircraft in the way. And yet, night flying comes with its own set of serious challenges. Fatigue is the most significant. Flying a heavy cargo aircraft at 3 in the morning is not the same as flying a passenger jet at noon. The human body is not designed to be at peak cognitive performance in the early hours of the morning. Aviation regulators around the world set strict limits on how many hours cargo crews can fly and how much rest they must have between duties. Airlines operating cargo fleets invest heavily in crew scheduling systems designed to minimize the physiological impact of night operations. But the challenge never fully goes away. Night cargo operations require a workforce that is permanently running against the natural human sleep cycle. There is also the question of noise. Many airports around the world impose strict curfews on night flying, precisely because the communities surrounding them have fought hard for the right to sleep. London Heathrow has some of the most restrictive night flight rules of any major hub in the world. Cargo carriers operating at curfew-restricted airports have to plan their schedules around those limits with surgical precision. A flight that lands even a few minutes after the curfew window closes can face significant financial penalties. A pattern of late arrivals can result in the loss of a night flying permit entirely. This is why the routing of cargo networks looks the way it does. Instead of flying directly between every origin and destination, cargo carriers use a hub and spoke model. Packages from dozens of smaller cities are consolidated onto a single aircraft flying to a central hub. At the hub, they are sorted and redistributed. This consolidation is what makes it economically viable to fly large jet freighters at night. A Boeing 777 freighter carrying 40 tons of mixed cargo from a hub to a regional airport is a profitable operation. A Boeing 777 freighter flying half-empty between two small cities at 3 in the morning is not. The economics of cargo aviation are brutally unforgiving in this regard. Passenger airlines can generate revenue from ticket sales, baggage fees, seat upgrades, and in-flight services. A cargo airline has one source of revenue: the weight it moves from one place to another. Every kilogram of unused capacity on every flight is money that cannot be recovered. So the hub and spoke model, combined with the overnight schedule, exists not just because it works logistically, but because it is the only configuration that makes the numbers add up. There is one more dimension to this that rarely gets discussed. The overnight cargo network is not just moving parcels, it is moving things that the modern world cannot function without. Pharmaceuticals that have to be kept at precise temperatures and delivered within tight windows. Automotive parts that keep assembly lines running. Fresh seafood and produce crossing continents overnight to arrive on restaurant tables the following evening. Medical equipment dispatched from a manufacturer to a hospital with hours to spare. The cargo that moves through the night sky is not an afterthought of the global economy. It is one of its most critical circulatory systems. Something else that rarely comes up in conversations about cargo aviation is the sheer scale of the aircraft involved. Most people picture a cargo plane as something modest, a small propeller aircraft dropping packages at a regional airfield. The reality is almost the opposite. The Boeing 747 freighter, one of the most widely used dedicated cargo aircraft in the world, can carry over 130 tons of freight in a single flight. Its main deck and lower holds combined offer a cargo volume larger than most people's homes. Loading one of these aircraft is itself an engineering challenge. Pallets of freight are built up in standardized sizes and shapes specifically designed to fit the contours of the fuselage. Specialist ground equipment lifts those pallets and slides them into position on roller systems built into the floor of the aircraft. A full load can take several hours to assemble, which is another reason why the overnight window matters so much. The ground time has to be long enough to load and unload properly, but short enough to make the delivery deadline the following morning. And the aircraft themselves are remarkable in ways that go beyond their size. A dedicated freighter does not need windows along the fuselage. It does not need overhead bins, galleys, or lavatories for passengers. That means the entire interior can be optimized purely for cargo. The floor is reinforced to handle the concentrated weight of heavy pallets. Tie-down points are built into every surface. Some freighters have nose doors that swing upward to allow oversized items to be loaded directly onto the main deck. Others have side doors large enough to accommodate industrial machinery, vehicle parts, or even other aircraft components. The flexibility of a modern freighter is one of its most underappreciated qualities. There is also the matter of what happens to passenger aircraft after their commercial flying lives end. A significant portion of the world's cargo fleet is made up of converted passenger jets. When an Airbus or Boeing aircraft becomes too old or too expensive to operate efficiently for passenger use, rather than being scrapped, it can be sent to a conversion facility. The passenger interior is stripped out entirely. The floor is reinforced. Cargo doors are installed, and the aircraft re-enters service as a freighter, sometimes flying for another decade or more. This conversion process gives older airframes a second life and provides cargo operators with a cost-effective alternative to buying brand new freighters. It also means that the aircraft carrying your overnight package may have once carried holidaymakers to destinations around the world. The environmental dimension of night cargo flying is also worth understanding. A fully loaded freighter flying a direct overnight route between two hubs is, per ton of freight moved, considerably more fuel efficient than the alternative of moving the same goods by multiple smaller aircraft or by road over longer distances. The consolidation model, where thousands of individual shipments share a single flight, spreads the environmental cost of that flight across an enormous number of packages. That does not make cargo aviation carbon neutral, but it does mean that the system, as it is currently designed, is more efficient than the alternatives available at the same speed and scale. Somewhere in the night, a large aircraft was climbing through 10,000 feet with your package in its hold. One of 10,000 packages on that single flight, all moving through a system so precisely engineered that a delay of 20 minutes anywhere in the chain can unravel hours of planning. That is what I find genuinely remarkable about the overnight cargo network. Not that it exists, but that it works every single night with a reliability that most people take completely for granted. Now here's something that connects directly to what we just covered. If cargo planes are flying through the night carrying tens of thousands of packages, how does every single one of those packages actually get tracked in real time from the moment it leaves your door to the moment it arrives? The technology behind that system is far more complex than most people realize, and it is already covered in another video.